Last time we talked about the future values of annuity, and we talked about the present value of the payment of an annuity. Today we're going to look at the present value of an annuity. When we talk about making payments, if you remember, we had like certain amount of payments made, and we projected this payment to the future. Yeah, we project these payments to the future. Then we said we're going to take this payment and then multiply it by the interest rate you're going to get until you get to the future, wherever that future is. When we look at present value, we're going the other way around. So in this case, instead of multiplying, we will be taking back, dividing. Yes? So first one I'm going to, second one I'm going to divide. So this is going to be the payment divided by 1 plus r to the power 1, and plus the second payment over 1 plus I to the power 2, and so on. Yeah? So this, I can write it as a multiplication, 1 plus I to the power negative 1. Remember, when we take this to the top, we make it a negative. Yeah? And this would be 1 plus I to the power minus 2, and so on. And this is exactly the same thing we did for the future value, but instead of the exponent are positive, now they are negative. So I'm not going to go through the same process we did. So let's go ahead and put the formula that we end up with when we get the present value. So the present value of an annuity is equal to the payment times 1 minus 1 plus minus NT divided by R over N. So basically, this is the formula for the payment. Yes. Again, all N is the number of compounded period per year. T is the number of years still. R is your interest rate per year. And then payment is how much payment you're making or you're receiving, whatever it is. And PV is the present value. Oops. Come on. Sorry about that. And PV is the present value of that annuity, what it's going to be. Let's go ahead and do that and see how that works. It says, Camila was in an auto accident. She sued the person at fault and was awarded structured settlement in which an insurance company will pay her $2,000 at the end of each month. Yes. So here we have the insurance is required to pay. So that's a payment, $1,000 every month. Okay. For the next 7 years. Okay. Also said, how much money should the insurance company invest now at 4.7%? So the insurance company decided, instead of making a payment every month, they decided to take a lump sum of money and invest it today at 4.7% to guarantee that she will receive her payment of $2,000 per month. Yeah. So that is not that big deal. So we're gonna find out how much money it's gonna be, or the insurance company must deposit today to guarantee that amount. So the present value, whatever the $1,000 worth for 7 years, they're worth some amount today. So this is the present value for those money. It's going to be the payment, which is 2,000 in this case. So it's going to be 2,000 times 1 minus 1 plus. Now the rate is 7%. So that's going to be 0.047 divided by 12. Again, remember the exponent is minus, right? Or is negative. So to the power negative, and we're looking at 12 times 7, that's for 7 years, divided by, again, R is 0.047 over 12. Now, one thing when you use a calculator to enter the negative here, you do not use the minus sign. There are two signs in your calculator. One is like that, and one is just a negative. You use this. To subtract, you use that. Okay. This one over here will tell you error. So once we do the calculation for that one, then the amount is going to be paid, or is going to be, the bar is 142,924.70. So basically, if the insurance company invested that much money today in a bank account, they will guarantee that this person will be receiving the $2,000 a month for the next 7 years. Okay? Any questions? All right, guys, online we've been having a whole lot of problem with the issue with the internet, I guess. We've been disconnected so much. If we are, say something when it comes back on. Any question on that? No? All right. So this is basically how we figure out this. So now, really this thing is used sometimes, like we don't do much our daily life unless you win the lotto. Got a choice between payment over the years or a lump sum at the beginning. So now you can calculate your lump sum amount and see how much it's worth today versus the future. Okay? However, we could use this formula. We could use this formula to calculate a payment required for a certain loan, which we do every time. If we want to buy some sum of money from the company and we make a payment over time. If you want to buy a house, you do the same thing, right? So now let's go ahead and convert this formula so we can use it for finding the payment. So if I divide this by 1, for instance, then, and I cross multiply, then we end up with a PV times R over N equal the payment times 1 minus 1 plus R over N minus NT. And to isolate the payment by itself, by all this portion. So this way, have the payment isolated. So then the payment will equal to PV R over N divided by 1 minus 1 plus R over N minus N. Yes? So now we could use this to figure out what would our loan payment be, or what would our mortgage payment be, or maybe even credit card payment be if we decided to pay the credit card in a certain amount of time. Yes, so we can do a calculation to figure that out. Okay, now let me put the formula up there because this is the one we're gonna probably use. So the payment equal PV R over N over 1 minus 1 plus R over N minus NT. Okay. Now let's go ahead and take an example. All right. It says to supplement his pension in the early years of his retirement, Hong plans to use $400,000 of his saving as an ordinary annuity that will make monthly payment to him for 20 years. So this guy decided to take part of his money, put it in some place where he will get monthly payment for himself for the next 20 years. So he used $400,000 for 20 years. Oops. The question is, it says if the interest rate is 5.2%, so we're looking at R equal 5.2%, and we're looking at monthly payment. So compounded monthly. Now the question is, how much would he receive in each payment? So we can figure out the payment by considering the $400,000 he's going to take it and put it in the annuity. So in this equal to 400,000 times 0.052 over 12 divided by 1 minus 1 plus R, which is 0.052 over 12 power minus. Now, 12 is the periodic, is the monthly, how many months in a year, times 20, which is your 20 years. So those $400,000 are going to guarantee him an amount of $2,684.22. So if he invested, even if he invested that much amount of money, right? So therefore, he will have that much. He will be collecting that much every month for the next 20 years. Okay. Let's do another example. This example, we're going to expand more. Because we're going to talk a lot about things to come. It says in October 2016, let's not do that. Okay, it says on October 10, 2016, the average rate for the 30 years fixed mortgage was 3.37%. So now we had mortgage rate at 3.37. Yep. It says assume a down payment of 20% on a home purchase of 20 down payment. Cost of home is $285,000. Yeah. Okay. Find the monthly payment needed to amortize this loan. So we need to amortize that loan. Another way, I need to get house. Yeah. So I need to figure out what would the monthly payment be. Now remember, in these calculations is a little bit different than reality, because reality, what they do, they add taxes, add insurance to your payment. Now we're looking only at what the payment is going to be for just the loan itself. Okay. So how do I figure out? Well, first of all, I need to figure out how much money I need to borrow to buy that house. Because of the fact that we're going to put 20%, so we're not going to borrow the whole amount. So we're going to borrow the amount minus the 20%. So let's figure out what the present value is for the loan. So it'll be 285 minus the 20%, which is 0.2 times the amount itself. Okay? Then, if we go ahead and multiply these, the amount would be $228,000. So this is how much money you're going to be in from the bank to borrow to buy the house. Yeah. So now we need to figure out what would your payment be. The payment is, I'm going to use the formula up there using this present value. It'll be 228 times the interest rate for the house is 0.0337. Divide that by 12 over 1 minus 1 plus 0.0337 divided by 12 to the power negative NT. Yes. Now, N is 12T is 30 years. Yeah. So that's going to be minus 360. So that should give me a payment of $1,007.35. $1,007.35. Now, let's say you made payment for 10 years, and you need to know how much money you still owe. Yeah? You need to know how much money you still owe. Let me go back to the line I drew at the beginning. Yes? Today, here is 10 years from now. Okay? If I were making a payment of $1,007, and I said, I can take this, take it back, right? To figure out the present value for that, because this is how much you owe. If I take all these payments to the beginning, right, that will give me the present value of the loan itself. But we didn't. We already passed how many? 10 years, right? So now, let's say we're here. If I want to know how much left over, I can take these, project them back to the beginning. Right? So we really need to use the present value formula again, right? But this time, instead of the period is 30 years, instead of the period 30 years, I've already paid 10 years, so I'm going to use for period for what? The leftover of the years, which is 20, yeah? So to figure out how much money you still owe, I figure out the present value for the loan. So what is that present value of the loan? It's going to be the payment times 1 minus 1 plus R over N. I'm going to write the formula down first, right? To the power, we're looking for the whole loan, yes? I would say NT, yeah? But I'm not. I'm looking for the leftover, right? I'm just going to subtract whatever payment I made, yeah? I'm going to subtract whatever payment I made. This would be the leftover. X would be how many payments until now. If I say I made 120 payments, correct? And then the rest of the formula would be the same. Yeah? The rest of the formula will be the same. So if I want to figure out how much I owe after 10 years, I can use the amount, that's 1,007, 1007.35 times 1 minus 1 plus 0.037 divided by 12 to the power. Now the total period is 360. I made 20. Let me just put it this way. Minus 360 20 to the power 360 minus 120, and that will be a minus there. Yeah. Divided by 0.37 over 12. So that should give me. Let's see if they have that amount. 175,710. 175,710.23. So after 10 years, I still owe that much money. Yes. So this is. Let's change that and call this B for balance. Yeah. Let's call that B for balance. So this is the leftover, or this is how much you still owe for a particular loan that you, after making certain amount of payments. Yeah? Now, how does amortization work? How does amortization work? When you borrow money, at the beginning you owe whatever it is you borrowed. Now, after 1 month, you make a payment. Now, definitely you owe less. Yeah? So the payment you made, a part of it goes to interest and part of it goes to principal. Which part and how much goes to principal, how much goes to interest, let's go ahead and do a little bit of amortization schedule so we know do it. Okay? So let's use the same example we have because we already know the amount, the stuff. So this is how much you borrowed. Let's go ahead and put that over here. So this is your 228,000. This is how much you borrowed. Payment was 1007.35. Okay? And this is what I'm going to be looking at. Okay, let me erase all of these. Because when you borrow, when you get money to buy a house, the bank gives you a payment or a big list telling you this is how much you're going to be paying every month. So see what we understand. So let's make this table over here. I'm going to make it as big as I can so I can put all of the information in there. So first, this is the payment number. Pay number. Yeah? And here you have how much you paid. So payment amount. Okay? Part of the payment is interest. Interest, let me just give some more space. Yeah? And part of it is principal. Correct? And over here, you have your balance due. How much of the money left over every payment you make? Okay? At the beginning, you made payment number 0. Yes? At the beginning, you made no payments whatsoever, right? But you owe what you started with, which is $228,000. Yeah? Now, months passed, you're already into the first payment. You made a payment of whatever it says, according to our calculation, $1,735. Now, I need to know how much of that money was interest. Well, you normally pay interest on your balance, correct? I mean, you don't pay interest on something else. Whatever you owe, this is what you. So how much interest I'm going to pay on this amount for 1 month? Well, I'm going to take that amount. It's going to be 2,8,000 and multiply that by the interest rate for 1 month. Yeah? And the interest rate for 1 month is your interest rate, which is 0.0337 divided by N, which in this case happened to be 12. Okay? So this is how much interest you're going to pay on this amount for 1 month. Okay? Now, figuring that out, let me see how much is that going to be. Hopefully, I can pull out those numbers. So let's move to the calculator. Okay, so it's going to be 228,000 times 0.0337. Divide that by 12, and that's going to be for the first month $630 and $640.30. So that is how much you paid, part of, or this is what you paid for interest on the first month. Yes. Yes. So if you're doing it on a weekly basis, then you will divide by 52. So now, so I need to figure out portion of my payment went toward interest. So that's going to be 1007.35. I'm going to take away the interest, which is 640.30 cents. And whatever amount I get, this is your 1007.35 minus 640.3. So $367.05. That's how much I paid toward the loan. Yeah? This is how much we paid toward the loan. So now we need to figure out how much we still owe. And then to figure out how much you owed before, this is how much you paid. So the difference would be 228,000 minus 367.05, and that should give me 27. Was it 227? 9. So after I made one payment, now I still owe that much. Now here comes number 2. You make a payment and 1007.35. Yes. Then portion of that payment is interest. Done. How do I find the interest? Now I look at the new balance and I multiply the interest rate. The new balance is 227,638.95 times 0.037 divided by 12, and whatever number I get, this is my 632. That was 7, right? That's a 2. Okay. Yeah. All right. So now we need to figure out how much we did that. So let's multiply. Okay, I can't do that. Equal the result 10337 divided by 12, and that should give me 639.27 cents. So this is how much interest I paid the next period. If I take it from the balance, from the payment, that should give me over here 368.08, 227,632.95. So that should give me 227,264.87. So this is the second month. Yes. Now to figure that out, we figured how much we owed balance the month before, multiplied by the interest rate, gave me the interest. Subtract the interest from the payment I made. This is the portion I paid toward the balance. Subtract the previous balance from from the previous balance. That will give me the next balance. And of course, the third step would be exactly the same until you finish 160 of them. And that will give you the amortization for this particular loan. Okay? Any questions? All right. Let's take a look at this scenario. Says you wanted to buy a car. That car cost $25,000, advertised for $25,000, 0%. As for $25,000, 0% for 5 years. You try to talk the salesperson into getting the price down. Yes? He said, I can give you the car for $23,000 cash now. He said he can give you the $23,000 cash now. Okay? However, you don't have a $23,000 in your pocket. Luckily for you, was a banker in there. And the banker said to you, I can loan you the money. I can loan you the $23,000 you need to buy the car cash, but I need to collect interest on it. He said he will collect 2.9% interest. So now you are in the middle of a scenario where which one of these two deals is better for you? Which one of the two deals is better for you? And of course, both of them, they go for 5 years. Well, to figure it out, first, I'm going to look at the option that car dealer has. I want to compare. This is how you compare the payment. If that's what you go aiming for, you will compare the payment for each one. Since both payments are exactly the same amount of years, then you see which one has a higher payment, then you leave that. Yes? So option one, you're going to pay $25,000 over 60 years. Yes? 60 months. So payment is, now notice since there is no interest involved, all I have to do is the amount divided by 60, because there is no interest involved. So that's going to be 25,000 divided by 60, and that should give me, I think it's $416 and perhaps 66 cents. So that would be the price I'm going to pay for option number one. So option two. Option two is, instead of $25,000, you're going to be paying how much? $23,000, because that's $23,000. So for this, the payment formula to figure out how much payment I'm going to be making every month. Yeah? So the payment is PV, which is 23,000 times R is 2.9, so 0.029 divided by 12 divided by 1 minus 1 plus 0.029 to the power minus 60, because it is minus NT, and NT is 5 times 12. Yeah? So let's figure out what that amount is going to be if I go with this route. Okay. So now we look at 23,000, multiply that by 1029 divided by 12. That should give me that, divided by 1 minus 1 plus 1029, divide that by 12 to the power of, to the power minus 60. And that give me $412.26. Yep. So that's how. Now the two amounts are, yeah, even though there is a $2,000 difference, yeah, but they are very close to each other. Now, this will be better if continue making payment on the car until it stops. Okay. However, well, in both cases it would be better because it's always cheap, right? If we decided to go for a balloon payment later on, say pay it 2 years and then after 2 years pay off the rest of it, that's okay. But suppose we ended up with some money over here more, yes? If I want to make a balloon payment, this would be better. I don't want to make a balloon payment, this would have been better if that was more. Okay. Any questions? Okay, that's it for today. Let me